So, welcome students. So, today we will study the third part of pharmaceutical analysis topic. So, in the last two parts we have seen introduction about pharmaceutical analysis, right? And also we have seen how to prepare different type of solutions using different concentration methods. So, today we will continue on that one. So, last in the part 2 we have seen the normality, right? What is normality and what is gram equivalent. So, today we will go a little bit more on this topic, more on this normality topic. So, in this normality we have seen this gram equivalent, right? Gram equivalent and equivalent weight. So, what is gram equivalent of an acid? It's a molecular weight divided by the number of replaceable H plus ion, that is the protons in that one. The acid contains protons, right? HCl contains H plus proton. Sulfuric acid H2SO4 contains 2 H plus, so H plus. So, that is the number of replaceable hydrogen ions, protons. And in the case of base, how to calculate the gram equivalent? It's a molecular weight of the base. For example, if it is sodium hydroxide, it is the molecular weight of the sodium hydroxide divided by the number of replaceable OH minus ion, hydroxide ion. Okay. So, let us see some calculation of the base. We have last in the part 2 we have seen how to calculate the equivalent weight of acid. So, we can check how to calculate the equivalent weight of base. It is the same principle, same formula. Of course, is the base sodium hydroxide is dangerous, so you have to be careful because it can cause it's a corrosive, it can cause skin damage and leads to heavy pain. So, gram equivalent of base is the molecular weight, right? The molecular weight of the base divided by the number of replaceable OH minus ion, hydroxide ion, OH minus ion. So, it is hydroxide ion. In the case of acid, it is H plus ion, right? In the case of base, it is the OH minus ion, it's opposite. So, for example, the case of sodium hydroxide is equivalent weight of sodium hydroxide, right? Gram equivalent and equivalent weight are same. The molecular weight of sodium hydroxide is 40 gram per mole divided by the number of replaceable OH minus ion. There is only one OH minus ion, so it is only 1. So, answer is 40, right? Equivalent weight of sodium hydroxide is 40, which is the same as the molecular weight. Molecular weight also 40. So, molecular weight also 40 for sodium hydroxide and equivalent weight also 40 for sodium hydroxide, because there is only one replaceable hydroxide ion in the base, in the sodium hydroxide. So, see this reaction, sodium hydroxide produce 2 sodium ion, right? So, it should be one sodium ion and one hydroxide ion, one OH minus ion, one Na plus ion. So, because of this one OH ion or replaceable OH ion, equivalent the number of replaceable OH ion is 1, so equivalent weight is 40. Let us see another interesting example, the sodium carbonate, Na2CO3, sodium carbonate. So, in this one there is no hydroxide, no OH minus ion. So, how to calculate the equivalent weight or gram equivalent weight of this base? So, for this case we have to modify this equation slightly. Okay, so you can see that I have modified this equation, this formula, and I have given 6A as the formula number. Okay. So, what is the formula? Now, the formula we can modify slightly. The gram equivalent weight of base, that is the sodium carbonate, will be molecular weight of this base divided by the number of charge. So, not the number of hydroxide ion, we can also use the number of charge on the ions. Okay. To understand it better, we will follow the coming reaction scheme. So, equivalent weight of sodium carbonate is 105.98, which is the molecular weight of this one. So, you can get this molecular weight from any textbook or internet, molecular weight of sodium carbonate divided by 2. Now, the 2 is the number of charge on the ions. How this number of 2 is coming, I will show you in after some time. Okay. So, how this 2 is coming. So, answer you can see that answer is this 105.98 divided by 2 is this one, 52.99. That is the equivalent weight of sodium carbonate. So how this 2 is coming? Number of charge on the ion. So sodium carbonate gives, when it breaks down, gives 2 sodium ion, 2 Na plus ions. So 2 positive charge and 2 negative charge of carbonate CO3. Okay, CO3 2 minus ion. So this, because of this 2 minus charge is coming, I have inserted 2 in the formula. So this 2 is coming from the charge on the ions. Okay, there are 2 Na plus ion and 2 negative charge of carbonate CO3 2 minus. So 2 minus. This is number of 2. This is how this 2 number 2 is coming in the formula. It is the number of charge on the ions. Like this, you can derive equivalent weight for different bases, right? Using the same formula, change a little bit here, number of charge or number of OH minus ion, according to the structure of the compound, okay, or the formula of the compound, and then you can calculate equivalent weight of any base or any acid. So now let's move on and calculate the normality, the concentration, how to concentration based on the normality terminology. So let's see how to calculate the normality of a solution. So here I have given this new formula, which is very easy to use and calculate in one step to get the normality of any acid or any base or any chemical if you want to make a solution. So normality N is gram of solute. Solute means any chemical, solid chemical, which can be dissolved to make a solution, right? We have seen the solute in the introduction. So if students are having problem in understanding this word solute, solvent, solution, you have to watch this part 1 to understand this meaning. So grams of solute divided by the volume of solution in liters. Okay, not in milliliters, it's in liter. So volume of a solution in liter multiplied by equivalent weight of the solute, equivalent weight of any chemical. So let's make a solution. Okay, for example, let's make a solution. How to prepare a 1 normal solution of sulfuric acid. H2SO4 is a sulfuric acid in a total volume of 1 liter. Okay, we need to make 1 liter of sulfuric acid. Okay, and then the concentration should be 1 normal. How to make this? So use this formula to calculate the number of grams of solute needed, right? So normality we know, normality is given in the question. So we need to make 1 normal solution. And how much is the total volume of solution in liter? It's also given in the questions, right? I have given total volume needed is 1 liter. So 1 liter needed and 1 normal concentration needed. So we just want to calculate the grams of solute needed. Equivalent weight we have calculated already, right? In the previously we have calculated the equivalent weight of sulfuric acid. If you don't know, check the part 2. Check the part 2 of this video lecture. So equivalent weight is sulfuric acid should be half, right? Half of the molecular weight. Molecular weight is 98. Equivalent weight is 49 because there are 2 replaceable H plus ion, right? You can check. So let's put all this value in this formula and try to get the value of number of grams of the sulfuric acid needed. So now let's check. So use this formula, this new formula, formula number 7. We already know the normality. Normality is 1 normal, right? And the grams of the solute we don't know, so I put the question marks. Divided by the number of solution, that is in liter. Okay, so it's 1 liter. This we know already from the question. And at last, we also know the equivalent weight of sulfuric acid, which is 49. So we just need to get the number of grams of solute. That is, I have given this question marks, right, red color. So you just have to cross multiply. This will go here, 1 will go here on the left hand side of the equation, and you will get the 49 grams of sulfuric acid is needed. Simply, this 1 get multiply, 1 get, simply you get the answer is 49. So to make this solution, we need 49 grams of sulfuric acid. So what you have to do practically in the lab? You have to weigh, because sulfuric acid is a liquid, you have to weigh the liquid in a dropper or something in a small beaker, right? 49 gram you have to weigh, and then you transfer this 49 gram into the flask and make up to 1 liter of this. Total volume should be 1 liter, right? This is how you make the solution of a desired concentration of sulfuric acid. So let's say we simply change some number and see another example how to make another solution. How to prepare one normal solution of sulfuric acid? See, but here the total volume here it is given is 2 liter. Okay, previously it is 1 liter, so 2 liter. So what to do? How to make this solution in 2 liters? Let's see. Same formula you can apply, right? Same the formula number 7 can be applied, and let's see how to get the normality value. So we know from this equation that the concentration is 1 normal, right? So I put here 1 normal. Grams of the solute needed we don't know, and then volume of the solution here it is 2 liter. This is a change compared to the first example we have seen today, and then the equivalent weight is 49, right? So the total gram of sulfuric acid needed is 98, right? We multiply this one, and here it is only 1, so if we cross multiply this, we get this 98 grams of sulfuric acid is necessary to make this 1 normal solution in 2 liters, right? So you just have to double the amount of sulfuric acid. If you want to make it in same concentration 1 liter, you need 48 gram. In 2 liter, we need 98 grams of sulfuric acid. That's all. So this kind of very solution preparation is very important in everywhere. If you go to any labs, any company, any industry, or even in the academic field, if you conduct an experiment in this in chemical or in pharmaceutical labs, the solution preparation is universal. So understand better is very important. So now let's see a last example for this. How to calculate 3 normal solution of acid. 3 normal. See, now the the volume is changed, same 1 liter, but we need to get high concentration. That means 1 liter of sulfuric acid solution, but the concentration should be high. So how to prepare this solution? 3 normal solution of sulfuric acid in total volume of 1 liter, right? Of course, use the same formula and see how we can calculate. So what we need to make 3 normal solution, right? I have given here. This is in question also. And then now we need to make we need to find out the number of grams of the sulfuric acid, the number of grams of the solute, which is sulfuric acid here. Volume is given is 1 liter, right? This is the volume. And equivalent weight we already know. Equivalent weight of the sulfuric acid is 49. So we need to extract the number of grams value from in this equation. How to do this? So you simply multiply this and then you cross multiply. Okay, so 49 into 3 is 147 grams of sulfuric acid is needed to make this concentrated solution. That's all. Now let's change slightly the question. Now instead of acid, we need to find out how to make the solution of a base, right? In a total volume of 1 liter, the base given is sodium hydroxide. So how to make the sodium hydroxide of concentration 2 normal in 1 liter? It's the same formula we can use. 2 normal solution we needed, right? 2 normal concentrated solution we need to prepare. Grams of solid we need to find out. Liter of the solution is given in the equation is 1 liter, and equivalent weight of the sodium hydroxide we already know, we already calculated today in the equivalent weight calculation, gram equivalent calculation, which is 40, right? There is only one replaceable NaOH in the OH minus ion, so right. So the molecular weight divided by 1 is 40. So molecular weight and equivalent weight is same in the case of sodium hydroxide. So I given here it is 40. So how to calculate the number of grams of sodium hydroxide needed? 40 into 1 into 2. So if you cross multiply that, you get 80 grams answer, which is needed to make this, to prepare this solution, to prepare this 2 normal solution. So far we have seen what is normality, right? Or how to calculate, first how to calculate the gram equivalent, because you are equivalent weight. This is very important. This comes in this equation, and then we need to we have calculated. We have we have seen the examples of how to calculate the equivalent weight, both in the case of acid and base. So and also it's same for everything, not only acid and base. It's also for other chemicals also. Can be same formula can be applied. And then we have seen this normality calculation, how to calculate the normality or how to make a desired concentration using normality as the concentration variable. By using this formula, grams per solute divided by volume multiplied by this equivalent weight. Okay, it's underneath this. So now let's move on to the next concentration term, percent concentration, how to make a solution based on the percentage. Okay, so people are making different concentration, 10% solution of something, let's say 10% solution of a medicine, a drug, ibuprofen, paracetamol, and like that. So how to make this kind of solution, 10% solution, 5% solution. So this is another important concentration term used in everywhere, even medical and in chemical industry, to prepare a different percent concentration of the drug or chemical. So let's find out how to make this percent concentration and what are the formulas involved. So let's see, the percentage concentration can be two types. One is a weight percentage. Okay, this involves weight. We have to weigh the chemical and then make the percentage. The second percentage concentration type is the volume percentage, volume percent concentration. So volume means you have to measure the volume and then make a desired percentage concentration based on the volume of any chemical. So what are the formula involved to calculate this weight percentage and volume percentage? So weight percentage volume will be, the formula will be weight percentage equal to weight of the solute, okay, in grams divided by the volume of the solution in milliliters multiplied by 100. So this is 100% we need to convert. So that's why this 100% term is coming. Okay. So the volume percentage is the second formula, is the volume of the solute divided by a volume of the solution. So how much volume of the solute divided by the volume of this total solution multiplied by 100. So let's see an example. First for the weight percentage, how to calculate the weight percentage. So the formula is weight percentage equal to weight of the solute divided by volume of solution into 100, right? So let's see an example how to prepare the 10 weight percentage of sodium chloride. So what is sodium chloride? Sodium chloride is a common salt, right? Salt we use for the everyday use. So how to prepare a 10 weight percentage of sodium chloride in this example, how to calculate this. So use this formula. So we need to find out a 10 weight percentage of sodium chloride, right? For that, how to do that? We need to dissolve a 10 gram of sodium chloride in 100 ml of the solution, the water, to make the total volume. Multiply by 100, right? Multiply by 100, you will get 10%, right? 10 divided by 100, multiply by 100, you will get 10%. So this is how you have to make. You have to take 10 grams of sodium chloride and then dissolve in water and make up to 100 ml. That will be a 10%, right? 10 divided by 100 into 100. So this is how we have seen how to make the sodium chloride solution by using weight percentage. Let's see how to prepare a volume percentage. Okay, this is volume percent. The second example, this is actually not correct. It's weight percentage, not volume percentage. Please change it. So volume percentage is volume of the solute in a milliliter divided by the volume of the solution in milliliters, okay, into 100. Let's see an example how to prepare a 10 volume percentage of acetic acid. So what is acetic acid? CH3COOH. It's a very weak acid compared to HCl and sulfuric acid. Acetic acid is used for even for cooking purpose, right? So how to make this 10% very low less concentrated acetic acid solution? 10 volume by volume percent. Okay, in the weight case it is 10 weight by volume percent. So weight percentage. Here it is volume percent means 10 volume by volume percentage of acetic acid. You can make it by measuring the 10 milliliters of concentrated acetic acid. Okay, 10 milliliter you have to take and then make up to 100 milliliters of water using water. So total will be 100 ml. So how to make this? 10 ml of acetic acid you have to take it and 90 ml of water, right? Total will be 100. Total will be 100. So it should be total solution, volume of the solution. So 10 ml divided by 100 ml of the total solution using water will give you the 10%, right? 10 divided by 100 will be into 100 will be give you the 10% of the solution. So like that you have to make, you can make the weight percentage or the volume percent of any chemical using this two formula given. You can also try some other like how to prepare a 20 volume percentage of acetic acid. How to make that 20 volume? You have to measure 20 milliliter of acetic acid, okay, and then make up, add the water slowly and then make up to total volume should be 100 milliliter of water, right? 100 milliliter. So 80 milliliter of water you have to add 20 and then you will get the 20 volume percentage. So here in this one I have shown you how to make the 10 volume percentage. Similarly, you can also make 20, 30, 40%, whatever may be, by using this simple formula. So last for today, how to prepare parts per million concentration of any chemicals or any drugs. So this parts per million is meaning is how to, this concentration will be very low. So to make very low concentration, people use a chemist or the pharmaceutical chemist use this term for making the concentration. Parts per million. So in million, how many parts of a chemical is present, right? So what is parts per million? So parts per million is a mass of the solute. Solute can be any chemical or drug which is dissolved to make a solution, right? Solution is solute plus solvent solution. So in this equation both are coming, solute and solution is coming. Okay, so you should understand the terms involved. So ppm or parts per million equal to mass of the solute in grams divided by volume of the solution in milliliters multiplied by 10 to the power of 6. Okay, 10 to the power of 6 means 1 having 6 zeros. So 10 to multiply by 10 to the power of 6. This is the equation for formula for calculating the parts per million, and this equation I have given you the formula number is 10. Okay, so we have so far we have seen 10 formulas. So students are required to remember all these 10 formulas to calculate different solutions based on different concentration terms, normality, molarity, parts per million, percentage, etc. So let's see an example of how to calculate parts per million of any chemical using this formula. So in this example I have given the question, what is the concentration in ppm of 2 grams of sodium hydroxide? So what is given? 2 grams of sodium hydroxide we have given, okay, and then the total volume of solution is 5 liter. So that in the 5 liter flask 2 grams of sodium hydroxide is there. Okay, the total volume is 5 liter means 2 gram of sodium hydroxide plus added water, slowly added water, 5 liter water, and then dissolve the sodium hydroxide. This is the solution. Okay, so in that solution what is there? 2 grams of sodium hydroxide is there, made up to 5 liter in the water, using water, right. So what is the concentration in ppm, parts per million? Okay, in million, how many parts of sodium hydroxide is present? Okay, in the million parts of solution, how many parts of sodium hydroxide is present? That is the question. So ppm we need to calculate, right? That's why given in the red color. Okay, we need to calculate the ppm. Okay, ppm in this equation is on the left hand side. What we know is the mass of the solute. So the total weight of the solute here it is sodium hydroxide, right? Solute is sodium hydroxide. 2 grams. Total volume in milliliters. So you have to carefully change the 5 liter to milliliters. So 5 liter, how to change? 1 liter is how many milliliter? 1 liter is 1000 milliliter, right? In 1 liter there are 1000 milliliters are present. So in 5 liter there are 5000 milliliters of solution is present, right. So I have changed here is milliliter, because in the formula we have to calculate in milliliters only. Okay, you have to change it. You have to input this value in milliliter. So 5000 milliliter multiply by 10 to the power of 6, this factor. So what you will get? So you can divide 2 divided by 5000 and then multiply by this value, you will get it and check it. You will get a 400 value, right? 400. What is that? 400 ppm. So there are 400 parts of sodium hydroxide is present in the solution. This is what we calculated using this term. So this is how you can calculate the solution concentration by using this concentration term, parts per million. Similarly, you can calculate difference, like for example 1 gram of sodium hydroxide in 10 liters, or very small concentration 1 milligram of sodium hydroxide in 1 liter. How to calculate that 1 milligram? So you have to change first to grams, right? Change milligram to gram and then change liters to milliliter and then calculate, same thing. Okay. So how to calculate, change gram to milligram? You have to divide by 1000, right? You have to divide by 1000. For example, 1 gram, for example 100 milligram of sodium hydroxide. How to change to gram? 100 milligram divided by 1000, you get 0.1 gram. 0.1 gram, and then you have to put this value 0.1 gram here in the equation. So you can students can try different concentration, different values, change the value here, and then find out how much ppm is coming. Okay, because in the exam I will change for brainstorming session, I will change the different values here and then give you the question. So you have to able to understand and solve this problem. Whatever grams or milligrams or liters or milliliter is given in the question. So this students should be practice enough to make it make this problem understandable. It can be applied in anywhere to make parts per million, normality, molarity, different concentration terms, percentage concentration, like that. So far we have finished the concentration, how to prepare the solution on different concentration terms. We have finished by on today. In the next class we will see how to make what is the primary standard, secondary standard, and based on this how to make solution, how to find out how many how much concentration is present in the solution by using some experimental technique. We will see in the theoretical sense. Okay, volumetric analysis, gravimetric analysis. We will see all this in the theoretical sense from the next class onwards. So this is end of this today's session. I thank all the students for concentrating on this video lecture, and I will see you in the next class. Thank you.